Now, this is Radio TV Phono Nut, and we have the business end of a General Electric all-in-one stereo, probably from the early to mid-70s. Has an 8-track tape player, AM/FM radio, and a record changer. Although I don't have the record changer, the person who owns this kept that. The complaint is that one channel is dead, and the person who owns this told me that this was a Hurricane Katrina survivor, so he'd really like to get it going again. He said not to worry about the 8-track or anything like that because he could take care of that himself. He just wants me to get the other channel working, and I'll demonstrate what we're faced with. Right channel, left channel. You might can hear there's a whisper there, but not much. And the volume is controllable by the volume control, so that tells us that our problem is past the volume control. It's likely in the final output stage. Okay, let's turn that down before we get a copyright strike. Okay, let's pull this apart and see what we can find out about it. I have no schematic, so it's going to be more or less a hunt and peck game. To give you a closer look at this, this is our tuner and IF board. I don't think we'll need to concern ourselves with that. This is our audio amp board here. This is most likely where the problem's going to be. Okay, I'm touching the input of the volume control with my finger, and you can hear we're getting a little bit of hum out of the left channel. Not what we should be getting, though. And when I turn the volume control, the hum varies. Okay, let's move here to this input point. As you can hear, the hum is much louder there. That's past the volume control, and the hum level is not dependent on the volume control setting. So that tells me that our trouble most likely lies between our volume control and this point right here. Now, keep in mind this is all low voltage circuitry here, so there's really no danger in me getting zapped by touching things. And when you don't have a schematic on a piece of equipment, then sometimes you have to use more creative ways of finding the problem. Okay, we now have a schematic for this amplifier, and this should help us out a great deal. Here's our AF amp transistor. The signal comes in on the base, comes out at the collector, goes through the tone control, up through the loudness control, on down the line through this Darlington driver transistor, and then that's coupled to the output stage. So, let me inject a signal, and the signal being the touch of my hand on a screwdriver, into the volume control and see what we get. Here's the left channel. As you can hear, we get a buzz, and the right channel we get a buzz. However, when we flip it to a signal, such as an FM broadcast, you can hear that it's just barely audible in the left channel. So that gives us a valuable piece of information. That tells us everything from the volume control on out to the speakers is okay. Our problem is somewhere back beyond the volume control here, possibly this AF amp transistor. Okay, let's check some voltages on that first AF transistor. First, we'll check the good channel just for a comparison. Let's look at the collector. We have 11.6 volts, emitter 0.5 volts, and base 1 volt, and that's pretty close to the schematic. Alright, on the bad channel, collector 16 volts, that's high. Emitter, 10 volts. And the base is 0. So that sounds like this transistor, looks like this transistor might possibly be leaky. Okay, actually I misspoke here. The base of the suspect transistor has 10 volts on it. It should be 1 volt. This has 16 volts. It should be, according to the schematic, the collector should have 9 on it, but the other one had 11, so we'll go with that. And the emitter, 0. Looking at the schematic, we have 9 point whatever volts on the collector. We come down, go back around through this, looks like a 5.6 mega ohm resistor up to the base. So if the transistor was not conducting, then there would be a substantial higher voltage on the base over what's listed here. I'm testing the transistor on the diode function on my meter. It indeed has an open base to emitter junction. Base to collector checks fine, but base to emitter is open. And this appears to be just a general purpose NPN transistor, so something like a 2N2222 or just about any little NPN silicon transistor should work fine in this. Okay, the transistor helped, but unfortunately we now have distorted output on the left channel. So there's more investigation that needs to take place. Okay, apparently this thing is a little bit fussier about transistors than I figured it would be. The first transistor I used, it was causing when all the distortion was taking place. And it was not happy with that transistor at all, and our collector voltage was running about 16 volts when it's supposed to be in the 9 to 11 range. It calls for an ECG 229 transistor in that application. I found an ECG 293 and it seems to work better, but it's still not 100%. I'm still detecting a little distortion. And now the left channel is louder than the right. Okay, at this point, just to satisfy my curiosity, I think I'll go to the parts house and obtain the actual correct transistor that goes in here, and then we'll go from there. Maybe I'll get lucky and the parts house will actually have what I need. It seems like here lately that they just don't have the stuff that they used to have, and they're not reordering when they run out. I know 20 years ago I was making trips several times a week to the local parts house. Now I'm lucky if I go by there once every 2 months. One thing I can do before I make that parts house trip is swap the right and left channel driver transistors around and see if that makes a difference, and then we'll know whether or not we need to make a trip to the parts house for the correct ECG or NTE specified part. Okay, I think we can save a trip to the parts house because swapping the transistors did absolutely nothing. It's still dull on the right channel, and it's a little bit louder and brighter on the left channel, so we need to now troubleshoot the right channel. The left channel appears to be okay, so my next course of option is to check the coupling capacitors on the right channel. If one of them is dried out, that could very well cause the slightly weak, muddy audio. Okay, I believe we have it taken care of. I found a bad solder connection on the amplifier circuit board and resoldered that, and it seems to be working okay. Also, these two capacitors in the audio output stage, 220 microfarads, 16 volts. These are replacements, NTE replacements that were replaced at some time. These have a date code of, I believe, let's see what the date code is on these, 1987. Originally this had standard polarized electrolytics, so even though these capacitors would still work, I just decided to put the polarized variety back in there, and we'll save the non-polarized ones for something that really needs that. Okay, let's see what happens.
He's talking in the middle. 101. After all the rejection that it's so...
Trick it out.
Rogers.com and experience.
Okay, that's FM.
Since we were children, we've been told to reach for the stars. It was great advice. Now it's a great gift.
Afternoon with thunderstorms likely. High.
I share family.
Norb, and thank you for being a part of All Action Sports Radio. My name is Wes. I'll be your host it's not this evening. We're still in the morning.
Okay, well, I think we have this one straightened out.
We get a lot of emails here at All Action Sports Radio.
So it should be ready to go back home now. Now, once again, he said not to worry about the 8-track player. He could fix that himself. In fact, I think he likes working on 8-track players, so I will leave that up to him. So just to recap, we found a open driver transistor on the circuit board, a bad solder connection, and just for the heck of it, I replaced these bipolar capacitors that somebody installed with the original type polarized capacitors. And we're back in business. Alright, that's about all I've got for this. Thanks for watching, and we'll do something else again soon.